Yeah. So this is my project. My project is called a chicken feeder, and the idea for this project was created because my dad has chickens. We have chickens outside in our house, and he usually goes in the mornings to feed the chickens. And when it's winter, it's really bad because his temperature are sometimes below zero, and he has to go in, change the water for the chickens, change the food, make sure there's feed on the buckets in there so the chickens can eat. So my idea was to create an automated chicken feeder where you can, by pressing a button, the food will be delivered into a bucket. So to do this, I have two buckets here. The big bucket, this one is the feeder bucket where the food is gonna be stored. So this bucket on the inside, it has a screw conveyor, which is gonna be pushing the food out, and that's gonna be done using this motor right here that I have. It's a 12-volt motor, which is gonna be activated by a relay. And I also have a power supply here. It's a 12-volt power supply, and I have the relay here that is gonna be activating that motor with the program that I have. So as an input, I have a keypad that is gonna allow the user to press any key on this keypad, and depending of which key someone presses, for example, if someone presses number 1 kilogram of food will be delivered into the fill bucket that is right here. For the purposes of this project, I don't have another big bucket, which is gonna be the fill bucket. In this case, I have this small one right here. Both of these buckets have weight sensors. They're underneath each bucket. The load cells underneath this one right here, and that one that is underneath between these two wood pieces right here. So each load cell has strain gauges on them, which when the gauges are into any mechanical force, the resistance of those gauges changes, which if you put that resistance, you can change that into a voltage. And with the little chips right here, the little ICs, these are called H711 ICs, and it also is an amplifier chip which amplifies the signal, that resistance signal, and changes into a voltage, making it more easy for the Arduino right here, the microcontroller, to control the whole program and to use those values as useful values for a programmer to have good readings. So in this case, I also have a LCD screen right here that is gonna allow the user to see how much food is being delivered, or to check the amount of food there is on any of the two buckets, either the right here, the feed bucket, or the fill bucket. So for the demonstration I have, anytime you press a key here, it's gonna be 0.1 of the kilogram that is gonna be delivered. So to make sure that the readings are accurate, I also have a small valence here, which already has preset food. So we have here 100 grams, that is 0.1 kilogram. I have two of this, of the same one. I also have one for 200 grams, that is 0.2 kilograms. And I also have this cup with 300 grams or 0.3 kilograms. So the function of the keypad is to turn the relay on. When a key is pressed, and wait for the load cell from the fill bucket right here to sense the value of 0.1 kilograms or 100 grams and make that relay go off, which will turn the motor off and stop the food being delivered to the fill bucket. So in this case, the motor is not connected to the relay because the 12-volt DC motor that I have and the 12-volt power supply I have gives the power supply gives the maximum capacity of the motor, which makes the motor spin really fast and has a lot of torque too, which is not really useful in this application. So to fix the problem, I have to get a gear motor which has a lot of torque and it has a low speed, which is gonna be perfect for this project, so the food can be pushed out through the screw conveyor over through the PVC pipe. Also, I have a dumbbell here. This is a 10-kilogram dumbbell, which is only to demonstrate that the load cell is having the correct values. So now, if I press key number 1 here, the relay should turn on and wait until 100 grams or 0.1 kilogram is delivered to the fill bucket, which will make the relay turn off. So there's that. And if we grab our 100 grams or 0.1, and this will be the function of the screw conveyor delivering the food. And you can see the relay on the bottom left will turn off when there you go. So it turns off. And if you see the feed is not enough for your chickens, it depends of the amount of chickens you have and everything. So if you think you need more, then you can just add another 1 kilogram of food, in this case just 100 grams. So you will press 1 again, and the value from that cell will just add up to the next value, so that the relay will turn on again, turning the motor on, and the food just will be delivered until 100 grams is again sensed by the sensor, and the relay will turn off like that. And each key has the same function, 1 through 9, meaning 1 kilogram to 9 kilograms. Each load cell is up to the maximum capacity of the load cells are of 20 kilograms, which is more than 40 pounds. That is enough for maybe like 6 chickens. My dad has a lot of chickens, so for a new project I will have to get load cells that have a larger capacity and make it waterproof as well, all the system to an enclosure to put up on the chicken coop. So also the LCD display and this key right here, the asterisk, when you press that one, the LCD will display the amount of food there is on the fill bucket as well or the feed bucket, so the user knows how much food he has on the feed bucket and if he needs to go ahead and just fill it up. So when you press that key, it will tell you how much food you have. So in this case, we delivered 0.2 kilograms right here with the 2 cups of rice, and we have the dumbbell. Remember that it was at the beginning for 10 kilograms. So right here we have 10.1 kilograms. That is pretty accurate. And having a system like this, it will make so much easier for the user to just go up to the chicken coop and just press any button he wants, and the food will be delivered by itself. So I also wanted to point out that at the beginning of this whole project, I wanted to include a remote control where you can use it as a keypad as well. So by pressing 1 kilogram of food will be delivered, and so on till number 9. But we didn't have the time, and this will be the next for future work reference. I would like to add up this to the whole project, which will make the project a better project. And also you can even control it now from inside your house, inside your home, so you don't have to go outside. And like I said at the beginning, it was more for my dad. So in the winter, when it's below 0 degrees outside, you don't have to go out and check the food for the chickens. You can only press a button, which will make a lot more sense, and it will be 1,000 times more convenient for someone that has chickens or any other type of animal, because you also can change the system and make it for like a dog or something, and also make sure that your program has a schedule where the food will just only be delivered the amount of food you want, and you can change that on the program, or you can change that on a different keypad, giving you options. And I think that's it for my project. Thank you.